All right, we're going to look at our next section here as we're looking at matrix operations. It says two matrices are equal if they have the same order and their corresponding entries are equal. So we're looking at matrices. All right, now when we talk about order, the order is the size of the matrix. So I want to make a note of that. Order is the size. And we do size with rows by columns. All right, rows by columns. So when you look at the order, let's go to these two matrices. We've got two rows, right, in this matrix, and we've got three columns. So this is an order of 2 by 3. 2 rows with 3 columns. And same thing with this matrix. The order of this matrix is 2 by 3. So to be equal, we're going to have, of course, the same size. They got to be identical, right? To be equal, we got to look the same on both sides. So we have to have the same size, which we do. Both of them have 2 rows with 3 columns. All right. Now, in these entries, we want to make sure that the corresponding entries are the same. So, for example, we take row 1, column 1. Well, it equals row 1, column 1 from our other matrix. So you can see row 1, column 1 entries are both -1. As we move over to row 1, column 2, we have a 0 in both. Right? And then we get to one of our unknowns, one of our variables. If we get to row 1, column 3, right, row 1, column 3 entries, we got a -2b and a 2. So those are corresponding entries. So that implies -2b must equal 2. So as we're going to solve that, right, let's go ahead and find b. We divide out our -2 on both sides, and that implies what? B must equal -1. So we just solved for one of our variables in this matrix equation. So we're solving a matrix equation. We found one of the variables. And we could check it, right? If we were to plug it back in, right, we were to check, right, -2 times b, -2 times -1 would give you 2, right? Let's check. We can plug that back in. If we go to our second row of entries, all right, here in row 2, look at row 2, column 1. So again, we've got 2a, and over here in the corresponding row 2, column 1 entry, we've got a 5. So again, to be equal, that implies 2a must equal 5. So now we've got an equation which we can go solve. So as we solve for a, right, what do we come up with? We come up with a equal to 5/2. So here's another unknown, another variable. Again, if we were to check, right, our answer, we know that 2 times 5/2 is equal to 5, which is what we want, right? We need 2a to equal 5. And it checks. So again, you can always check it, right? Plug it back in to do your check step. So just like earlier with -2 times b, -2 times -1, it equaled 2. It checked. Now as we move on, as we go to our next entry, we've got row 2, column 2. It's a 3. Row 2, column 2, over here is another variable. It's another unknown in this equation. So these must be equal. So that implies 7c must equal 3. So as we to solve that, right, as we solve for our variable, our unknown, we divide out the 7 on both sides, and we find the value of c being equal to 3/7. Right, so c is equal to 3/7, right? We could plug that back into our equation. So we wanted to do our check step. Right, we know that 7 times c, 7 times 3/7. As we simplify, that does equal the 3, right, that we wanted. So again, we just solved a matrix equation. So these are one of the operations of matrices, right? If we have a statement, an equation of matrices. to be equal, we must have the same order, the same size, and the corresponding entries must be equal. All right, well, moving on, let's go to our next section here. We're going to look at the operation of addition and subtraction on matrices. Now, with addition and subtraction of matrices, we must have the same size matrix in order for our sum and difference to take place. So in these examples, it says we have two m by n matrices. So they're the same size. We have m rows and n columns for matrix A and matrix B. And inside here, A sub ij is the ith row, jth column entry. B sub ij is the ith row, jth column entry. So those are our entries, our real numbers that make up these entries to our matrix. And so when we add up the two matrices, we take those corresponding entries and add them up. So the ith row, jth column entry of matrix A would have to be added to the ith row, jth column entry of matrix B. So for example, row 1, column 2, you got to add row 1, column 2 in the other matrix. And same goes with difference. We got to find the corresponding entries and subtract. So making a little note, right, we got to add and subtract, right, corresponding entries. So again, make sure they must be the same size, must be the same order or size. I'm going to look at it, order is size. So down here, let's go to our example here. Let's find the indicated sum or difference. So in this next problem here, we have a sum of two 2 by 2 matrices, 2 rows with 2 columns, we call a square matrix. So as we're finding our sum, we're going to have a 2 by 2 sum matrix. So our row 1, column 1 entries, right, we need to add those up. So -1 plus 1 would be our row 1, column 1 entry. And then as we go to our next entry, right, we can go to row 1, column 2. We've got a 2 and a 3. We would add those up, right? We need to add up those entries. And that would be our last entry in that row, right? Because it's only a 2-row, 2-column matrix, got 2 columns to it. And now we go to row 2 entries. So we have a 0 and -1. So we would have to add up those corresponding entries to get the sum for the sum matrix. And then as we go to our last entries, we got a 1 and a 2. We would add those up. All right, so in the end, what do we come up with? What does this equal? So in the end, we have a sum, -1 plus 1, which is 0. All right, we have 2 plus 3, which is 5. We have 0 plus -1, which is -1. And we have 1 plus 2, which is 3. All right, so there's our sum matrix. So there's the sum of those two 2 by 2 matrices. Right? So there's the sum matrix. So we added 2 matrices together, right? Again, same size. We can add, not, they're undefined. Going to our next example, example B, let's find the sum and difference matrix for a given matrix A and B. Now, if you talk about the size of these 2 matrices, these have 3 rows with 1 column. These are 2 3 by 1 matrices. So let's go ahead and find the sum matrix. What's A plus B going to equal? Well, we need to build in a 3 by 1 size matrix. Matrix big enough for 3 rows and 1 column. And we would add up the corresponding entries. So in our sum matrix, right, we're going to add 1 plus -1. So again, that's adding opposites. So if you notice, these 2 matrices are opposites of each other. So in the sum matrix, we should be getting a result of 0. We're adding opposites. As we go to the row 2, column 1 entries, we've got a -3 and a 3. So as we find the sum, we're going to see we're going to get 0. As we go to row 3, column 1, we got a -2 and a 2. So we add those together. As you can see, we're going to get 0 again. So in the 3x1 sum matrix, we get our 0 matrix. So yeah, adding opposites in matrices produces the 0 matrix. Just like it does with real numbers. We add opposites, we get a 0. So again, that's our 0 matrix. A matrix with zeros in each entry. Now, as we look at the difference of the two matrices, so let's move on. What's A minus B going to be? So we build in, we got to find this 3x1 matrix. So let's go ahead and subtract the corresponding entries. So we got 1 minus -1, and we go do the difference. As we move on to row 2, we got to subtract the entries. We got -3 minus 3. And we move on to the row 3 entries. We got to subtract -2 minus 2. So as we find the difference, we come up with 1 minus -1, that's 2, right? -3 minus 3 is -6. -2 minus 2 is -4. Right? So there's our difference matrix. Right? So there's the difference of those two matrices. Now again, your calculator will also do these for you. So if you ever want to check your work, right, you can do so on your TI. So if you want, let's get out your TI calculator, and I'll show you where matrices, right, where that command is located. So let's pull up our TI. All right, so in here, we've got, let's store in. So you'll see on your TI, above the inverse key on the left-hand side, it says matrix. So if you hit your second button in the inverse key, you'll go to your matrix menu, and it'll show you a bunch of lists of names. Now, the first thing you want to do is edit your matrix. So at the top, you got names, math, and edit. So if you go over to edit, you can type in the matrix. So if we hit, for example, matrix A, now, in our example, matrix A was a 3 rows, so you'll have to specify the number of rows, right, in each matrix. So go ahead and do that. All right, so let's go back in here. And let's type that in. Let's see if we can get that to come up here for you to show you. I'd like to show you, even though my calculator has frozen here. All right, but we'll see if we can pull that up in there. So let's see if we can get that to show here on your TI. All right, maybe we'll look at that later since mine's frozen. I'll come back. Maybe we'll do products in a little bit. I'll show you some on the calculator. All right, but right now, again, you can see it's pretty straightforward, right? Adding and subtracting. But we'll come back with some calculator review. Let's move on to another fairly straightforward operation. So we've done addition, subtraction. We'll move on to scalar products. Now, a scalar product is taking a scalar, a constant, and distributing it through your matrix. So if you have a number like K and a matrix A, right, well, you would take and find the product K times A, or the scalar product, I should say, which is obtained by multiplying each entry of A by the scalar, by the number K. Again, K is called the scalar of the matrix. So let's take what we've learned so far. Let's find 2A minus 3B. So here's a good test question. Let's find 2A minus 3B. So what would 2A minus 3B equal? Well, that would be equal to 2 times matrix A, which is, this matrix is a 3x2 matrix. So we'll go ahead and write in those entries. Minus 3B, and B is another 3x2 matrix. Same size, same order, 3 rows and 2 columns. All right, well, we've got a couple operations. We've got a couple scalar products, and we've got a difference of matrices. So eventually we're going to subtract corresponding entries. Let's go ahead and take care of the scalar products. So as we look at scalar 2, we're going to begin to distribute. So here's where we got to multiply through to each entry. So in the scalar product in 2a, we're going to have 2 times 3, right? And then we're going to have 2 times -2. We're going to have 2 times 4. We're going to have 2 times 5, 2 times 0, and 2 times -7. There's the scalar product. We're distributing that scalar through to each entry. So distributive property. Minus, let's do the same thing here. 3b. So let's take 3, distribute it through. 3 times -1. 3 times 3. 3 times 2. 3 times 4. 3 times 6. And 3 times 8. So that's your scalar product operation, distributing that scalar through. So again, in this 3x2 matrix, we had a 6, we had a -4, we had an 8, we had a 10, we had a 0, we had a -14. Minus, and then in 3b, we had 3 times -1, -3. 3 times 3 is 9. 3 times 2 is 6. 3 times 4 is 12. 3 times 6 is 18. 3 times 8 is 24. So again, there's 2a and 3b. And our last step, we need to subtract. So let's find the difference. So the corresponding entries. So row 1, column 1 entry, we got 6 minus -3. As we go to row 1, column 2, the -4 and the 9, -4 minus 9. So we found the difference. So again, those are the 2 entries there in row 1 as we combine those. Row 2, we've got 8 and 6. So go ahead and subtract 8 minus 6. And as we go to row 2, column 2s, we got a 10 and a 12. So 10 minus 12. And as we go to row 3, we've got the 0 and the 18. So 0 minus 18. And then as we move on to row 3, column 2, got -14 minus 24. All right, so in the end, here's our outcome. Here's the result of 2a minus 3b. 6 minus -3, that makes it 6 plus 3, or 9. -4 minus 9, -13. 8 minus 6 is 2. 10 minus 12 is -2. All right, row 3 entries. 0 minus 18, -18. -14 minus 24. All right, we got a -38. All right, so there's 2a minus 3b. Right, so we go ahead and combine those together. So there's our result. There's our outcome. Again, 2a minus 3b. So that's a good review. Scalar products, distributing a scalar, or constant. And then, of course, addition and subtraction. As long as we have the same size, these are 2 3x2 matrices, we can add up or subtract these corresponding entries. And our last topic we'll move on to is matrix multiplication. And let's take a break, and we'll come back to that.